Long time no see. Hello, hello. It's Mike here, and I would like to apologize. I been slacking on the readings. I'm not gonna lie, I have been slacking. I was working on the not all the way slacking. I was working on my CS50P final project. I completed that, passed the class, boom. Go watch my goals video for the month of August for a quick recap. Um, yeah, I was working on that, and then I went on a quick vacation back to see my folks. But I am back on the grind here, and I would like to also add am considering I am considering going back to school and getting a degree in computer science. Now, I already have a degree in human biology and a minor in chemistry. And my profession is I am a chemist. And I work as a chemist on a day to day basis. And so I would be going back for a second bachelor's degree. Um, so it's just a thought I've been having. So I've been researching that. So if anybody has any ideas for post baccalaureate programs or something like that, that just let me know. I'm very interested. But anyways, I am on Try It Yourself 7-1 today. We are starting off with this, and I am in a new format. I have the PDF version of the book up on the right side of my screen here, as well as our notes that we've been taking consistently throughout our time together here. But more primarily, I have the PDF version, so now that you can directly just follow along on the video rather than having it up on your separate screen. Now, I might fail to scroll as I read sometimes, but hopefully it's not too bad. But anyways, Try It Yourself 7-1 on page 117. Starting with 7-1 rental car. So let's go ahead and open up program here. We want chapter 7. Let's go in this file. We want to open up a new file called, how have I been labeling these? It's been a while. 700, okay. 7_1_ rental car dot py. Okay, so we're going to make a Python file here. Write a program that asks the user for what kind of rental car they would like. Print a message about that car, such as, let me see if I can find you a Subaru, which would be their rental car. So let's just say car is equal to, we want to ask a user, so an input to a question. We want to ask, what car would you like? And then we'll put a space to do that. So now we have that. Now we want to print a message, just simply print a message. What? This seems fairly easy. We were learning about module and stuff. Oh, whatever. So print quote f string. Let me see if I can find you a car. Okay, so now if we run the program, what car would you like? Let's do Toyota. Let me see if I can find you a Toyota. Because it's a car name brand, let's do capitalize method. Now find it again. Toyota. Cool. Simple enough. That was an easy one. Moving on to 7-2. 7_2_ rest. I can never spell this word. Rest. underscore seating dot py. All right. Write a program that asks the user how many people are in their dinner group. If the answer is more than 8, print a message saying they'll have to wait for a table. If the answer is more than 8, print a message saying they have to wait for a table. Otherwise, report the table ready. Okay, so user input equals the input function, and we want to ask how many people are in your party. Okay, so we need to, they're going to convert a string, so it's going to send back a string, and we're going to actually compare the string to numbers, so we need to initialize this as an integer, convert it to an integer rather. And so next on our list here of things to do, if the answer is more than 8, if user input is greater than 8, print your table will be ready in a few minutes. Okay. Elif user input. I guess I could just say else in this case. Print your now if I run this program, we've been your party 7, your table is ready. Let's try it again. Now let's go 8. Oh, still getting used to my new hotkeys here. 8, your table is ready. What? Like we're in a party. 9, your table will be ready in a few minutes. Your table is ready if it's greater than 8. So 8 is included. So I'm actually going to invert this. I'm going to say if answer less than 8, it doesn't really matter. It's just for my preference. Print your table is ready. Else, I'm gonna clearly distinct this just to get into the habit. Okay, so user input is equal to the integer conversion of the input function for how many people are in your party. If the user responds with input that is less than 8, it'll print your table is ready. If the user responds with something greater than 8, you'll print your table ready in a few minutes. So if I go ahead and run this code and run 8, your table. Oh, I don't have anything for 8 itself. Just say else here, I guess. Screw it. It's fine. Oh, there we go. 8. Your table ready in a few minutes. Is more than 8. Let's go back to what I had before. That was working. Not sure why I'm trying to get fancy here. If there's more than people than in 8, else your table's ready. So run this. 8. Table should be ready. Run this for 9. Table ready in a few minutes. Run this for 1. Table's ready. Cool. Moving on. Alright, that one was a little too easy. 7, 3. Multiples of 10. Okay. Ask the user for a number and then report whether the number is a multiple of 10 or not. So I need to use the modulo operator. The remainder of a okay. So if I want to know if it's a multiple of 10, so if modulo 10, so num equals the int input of a number. So if number modulo 10, so if you divide the number by 10 and that is equal to 0, then print num is a multiple ten. Else is not a multiple of 10. Okay, so if I run this code, ooh, get out of here, get out of here. And I give it a number, let's give it a number of 5. 5 is not a multiple of 10, okay? Let's try it again. Let's give a number of 10. 10 is a multiple of 10. Alright, let's try it again. Let's give a number of 1 million. Just a crazy large number. Yep, it's a multiple of 10. And how about one more time for something with a 9? Not a multiple. Boom! These ones were pretty easy. Feeling good about those. All right, moving on to page 118 here. Introducing while loops. So just for reference, I am reading off of the 3rd edition, whereas the PDF on my screen is the 2nd edition. So if there are slight discrepancies, that's why. All right, introducing while loops. Let me actually open up the chat. I don't have that open just in case anyone decides to pop in here. Okay, look at my docs, control panel here. Okay, cool. All right, introducing while loops. The for loop takes a collection of items and executes a block of code once for each item in the code. In contrast, the while loop runs as long as or while a certain condition is true. So while this is true, do this so many times. While I have this dollar bill in my hand, do this so many times. Oh, I dropped the dollar bill, stop doing it. So something like that, okay? The while loop in action. You can use a while loop to count up through a series of numbers. For example, the following while loop counts from 1 to 5. Counting.py. Current underscore number is equal to 1. Okay, so he sets a variable equal to the integer 1, while current number is less than or equal to 5. So while current number is less than or equal to 5, print current number, and then go ahead and increase the current number value by 1. So it's going to print 1, then it'll print 2, then it'll print 3, then it'll print 4, then it'll print 5, and then it'll see that the current number has been increased to 6, while current number is equal to 5 is no longer true, so the loop will stop. Okay. In the first line, we start counting from 1 by assigning current number the value of 1. The while loop is then set to keep running as long as the value of current number is less than or equal to 5. The code inside the loop prints the value of current number and then adds 1 to that value with current number plus equal to 1. The plus equal to operator is shorthand for current number equals current number plus 1. Python repeats the loop as long as the condition current underscore number less than is equal to 5 is true. Because 1 is less than 5, Python prints 1 and then adds 1, making the current number 2. Because 2 is less than 5, Python prints 2 and adds 1 again, making the current number 3, and so on. Once the value of the current number variable is greater than 5, the loop stops running and the program ends. The program you use every day most likely contains while loops. For example, let me go ahead and scroll up here. The programs you use every day most likely contain while loops. For example, a game needs a while loop to keep running as long as you want to keep playing. So it can stop running as soon as you ask it to quit. Programs wouldn't be fun if they stopped running before we told them to, or kept running even after we wanted to quit. So while loops are quite useful, letting the users choose when to quit. We can make a parrot.py program as long as the user wants to quit, run as long as the user wants to, by putting most of the program inside a while loop. We will define a quit value, then keep the program running as long as the user hasn't entered the quit value. So he comes up here. Does the zoom out on this make it too small slightly? Yeah. Okay. Let's keep it going here. Alright, we can make the parrot.py program run as long as the user wants to by putting most of the program inside a while loop. We'll define a quit value and keep the program running as long as the user has not entered the quit value. So prompt equals tell me something, I will repeat it back to you. Okay, so it's like a pair. Okay, prompt plus equals quote enter quit to end the program. Okay, message equals blank, while message does not equal quote quit. Message equals input prompt print message. We first define a prompt, okay, that tells the user there are two options: entering a message or entering the quit value, in this case quit. Then we set up a variable message to keep track of whatever value the user enters. We define message as an empty string, quote quote, so Python has something to check the first time it reaches the while line. The first time the program runs and Python reaches the while statement, it needs to compare the value of message to quit, but no user input has been entered yet. If Python has nothing to compare, it won't be able to continue running the program. To solve this problem, we make sure to give the message an initial value, or a blank string in this case. Although it's just an empty string, it will make sense to Python and allow it to perform the comparison that makes the while loop work. This while loop runs as long as the value of message is not quote quit. The first time through Okay, gotcha. The first time through the loop, message is just an empty string, so Python enters the loop. at message equals input prompt. Python displays the prompt and waits for the user to enter their input. Whatever they enter is assigned to message and printed. Then Python reevaluates the condition in the while loop statement. As long as the user has not entered the word quote quit, the prompt is displayed again and Python waits for more input. When the user finally enters quit, Python stops executing the while loop and the program ends. Gotcha. This program works well, except that it prints the word quote quit as if it were an actual message. A simple fix to this test is, so it reprints quit, okay. If message does not equal quit, print a message. Okay. So instead of just printing message right after prompt, they added this little line here. Now the program makes a quick check before displaying the message and only prints the message if it does not match the quit value. Quit. Okay. Using a flag. Okay, using a flag. In the previous example, we had the program perform certain tasks while given a condition was true. But we want to be more complicated. But what about more complicated programs in which many different events could cause the program to stop running? For example, in a game, several different events can end the game. When the player runs out of ships, their time runs out, or the cities they were supposed to protect are all destroyed, the game should end. It needs to end if any one of these events happen. If many possible events might... Okay, if... Why is this getting so crazy? It's getting all jumbled up here. If many possible events might occur to stop the program, trying to test all these conditions in one while statement becomes more complicated and difficult. For a program that should run as long as many conditions are true, you can define one variable that determines whether or not the entire program is active. This variable is called a flag. Okay, so let's quickly just jump over to definitions here. We want a flag, which is a program that should run only as long as many conditions are true. You can define one variable that determines whether or not the entire program. A variable that indicates whether on/off for an entire program. So this variable called a flag, let's go back to this here. This variable called a flag acts as a signal to the program. We can write our programs so they run while the flag is set to true and stop when any several event sets the flag to false. As a result, our overall while statement needs to check only one condition, whether the flag is currently true. Then all the other tests to see if an event has occurred that should set the flag to false can be neatly organized in the rest of the program. Let's add a flag to parrot.py from the previous section. This flag, which we call active, though you can call it anything, will monitor whether or not the program should continue running. So he has the prompt, like normal. Then he has active equals true. While active, message input. If message equals quit, turn active to false. So it's just basically like saying Okay, I'm entering the room. I'm turning on the light. Okay, while I'm in the room doing stuff, the light remains on. The light is my flag that I'm in there. Being in the room. Leaving the room turns off the light. I would turn off the light. That's the flag. Okay. Um, so let me add on to this quick definition. A variable that indicates on off our entire program when multiple conditions dictate whether a program runs a master switch. Okay. Let's add a flag to pair.py. Okay, we said to set the variable to active, we set the variable active to true, so the program starts in an active state. Doing so makes the while statement simpler because no comparison is made in the while statement itself. The logic is taken care of in other parts of the program. As long as the active variable remains true, the loop will continue running. In the if statement inside the while loop, we check the value of message once the user enters their input. If the user enters quit, we set active to false, and the while loop stops. If the user enters anything other than quit, we print their message. We print their input as message. Okay. This program has the same output as the previous example where we place the conditional test directly in the while statement. But now that we have a flag to indicate whether the overall program is in an active state, it would be easy to add more tests, such as an elif statements, for events that should cause active to become false. This is useful in complicated programs like games in which there are many events that should each make the program stop running. When any of these events causes the active flag to become false, the main game loop will exit. A game over message will be displayed and the player can be given the option to play again. Using break to exit a loop. To exit a while loop immediately without running any remaining code in the loop, to exit a while loop immediately without running any immediate code in the loop, regardless of the results of any conditional test, use the break statement. The break statement directs the flow of your program. You can use it to control which lines of code are executed and which aren't. So the program only executes code when you want it to. Execute code that you want it to when you want it to. For example, consider a program that asks the what am I reading? I'm like making up words here. It's ridiculous. For example, consider a program that asks the user about places they visited. We can stop the while loop in this program by calling break as the user enters the quit value. Prompt equals please enter the name of the city you visited. Enter quit when you are finished. While true, city equals input prompt. If city equals to quit, break, else print message. A loop that starts while true will run forever unless it reaches a break statement. The loop in this program continues asking the user to enter their names of the cities they've been to until they enter quit. Oh, I have been going to the slide up here. A loop that starts with while true, 1, will run forever unless it reaches a break statement. The loop in this program continues asking the user to enter the names of the cities they've been to until they enter quote quit. When they enter quote quit, the break statement runs, causing Python to exit the loop. Please enter the name of the city you have visited. Enter quit when you are finished. New York. I'd love to go to New York. Please enter the name of the city you have finished. Quit. Gotcha. You can use the break statement in any of Python's loops. For example, you could use a break statement in a for loop that's working through a list or a dictionary. So you could say like if you found the one you're looking for, break out of the loop and do something with that, like specifically in the list. Okay, on to page 122. Using continue in a loop. Rather than breaking out of a loop entirely without executing the rest of its code, you can use the continue statement to return to the beginning of the loop. Loop based on the result of a conditional test. For example, consider a loop that counts from 1 to 10 but prints only the odd numbers in that range. Current number equals 0. While current number is less than 10, current number plus equals 1. If the current number divided by 2 remainder is equal to 0, continue, print the current number. Okay, so what is this asking? Let me try to break it down first. So we set a current number variable to equal to 0 as a counter. We initiate a while loop, which indicates perform this while the current number is less than 10. Okay, each time we do it, we're going to add 1 to current number. If our new number is a prime number, is even, continue. Continue. Continue the loop. So it only wants to print the odd numbers. Okay, so if the current number is even, continue, meaning like continue the loop, pass over it, don't print, and you get to an odd one, well then you're going to break out of the if statement and print the current number. First we set current number to 0. Because it's less than 10, Python enters the while loop. Once inside the loop, we increment the count by 1. So the current number is 1. The if statement then checks the modulo of current number and 2. If the modulo is 0, which means current number is divisible by 2, the continue statement tells Python to ignore the rest of the loop and return to the beginning. If the current number is not divisible by 2, the rest of the loop is executed and Python prints the current number. Avoid infinite loops. Every while loop needs a way to stop running so it won't continue to run forever. For example, this continuing loop should count from 1 to 5. X equals 1. While x is less than or equal to 5, print 1. Or print x. X plus 1 is equal to 5. However, if you accidentally omit the line x plus equals to 1, the loop will run forever. Because x is just equal to 1 over and over again. Now the value of x will start at 1 but never change. As a result, the conditional test x less than or equal to 5 will always evaluate to true, and the while loop will run forever, printing a series of 1s like this. Every programmer accidentally writes an infinite loop from time to time, especially when a program's loops have subtle exit conditions. If your program gets stuck in an infinite loop, press Ctrl+C or just close the terminal window displaying your program's output. To avoid writing infinite loops, test every while loop and make sure the loop stops when you expect it to. If you want your program to end when the user enters a certain input value, run the program, enter that value. If the program doesn't end, scrutinize the way your program handles the value that should cause the loop to exit. Make sure at least one part of the program can make the loop's condition false or cause it to reach a break statement. VS Code has many editors displays output in an embedded terminal window. To cancel an infinite loop, make sure you click on the output area of the editor before pressing Ctrl+C. Okay. I'm going to take a quick 5-minute break right there before we move on to the Try It Yourself 7-4 at the bottom of page 123. Um, doing good so far. We've been streaming for 35 minutes. So just going to get a quick water break and bathroom break. I shared shared my final project video onto the CS50 subreddit, and it became my most popular video on my channel. Overnight, I'm almost at like 300 views right now, which is insane. So a lot of people were interested in seeing that example video of the final project, which was very neat and interesting. I also went from 7 to 14 subscribers from that video, so it 2x my subscriber count, which is also crazy. So thank you if any of you are new here. But, alright, jumping back in here. I know that was less than 5 minutes. It was only 2 minutes, but let's just keep it chugging. We only got 7 pages left in this study session for today. I'm getting to page 130, which is the end of chapter 7. So I need to go ahead and introduce while loops here. So, into my loops notes. So the while loop, this loop repeatedly executes a block of code as long as a specified condition is true or false. Let's just say let's just specify control plus C to break out to terminate a what's it called? Infinite loop. Okay, so true or false, an infinite loop. So we have a break. Used to explicitly stop the while loop and perform any remaining code outside. And perform any remaining code outside. Okay, so that's what the break thing did, but the continue Rather than breaking it, so break to exit a while loop immediately without running any remaining code in the loop. Side up loop. When you continue, and be used to explicitly stop and continue. Okay. Start over from the beginning. Cool. So that was continue and break. All right, so let's go ahead and take a peek at the 7-4 problem. Try it yourself. Pizza toppings here. Okay. Zoom in. All right, let's go ahead and open up a new file. Is there a hotkey to open up a new file? I don't know, probably. Pizza toppings. Pie. Okay, write a loop that prompts the user to enter a series of pizza toppings until they enter a quit value. As they enter each topping, print a message saying you'll add that pizza to their topping. So write a loop that prompts the user to enter a series of pizza toppings. Okay. So we first need to create an empty list to store the toppings inside of. We need to perform the loop. So while true. So while true, we want to prompt the user for topping equals input quote, what topping would you like? And then we'll say at a new line here, what topping would you like? Enter quote quit to end to complete when complete. Okay, so then if topping toppings dot append topping. Okay. So if topping is equal to quote quit, we want to topping else continue. So basically what this says is we have a toppings empty list, which is where we'll be storing the toppings that the user enters. We're going to repeatedly ask the user for toppings, so let's run a while loop. So while true, it's kind of a default way of saying it. Get while the loop is running, we want to get an input from the user for the toppings they would like. We want them to know that they can enter quote quit at any time to complete the order. If the topping deliberately equals quote quit, we will break our while loop. So elif topping, if there is a topping, then we'll go ahead and topping.append topping, and we'll go ahead and print that we want to topping added to pizza. Pizza. So elif there is a topping that was given that wasn't quit, we're going to go ahead and access our toppings list, our empty list, or whatever was in there, just the list in general, and we will append to that list the topping. And we're going to then just give a statement saying that we added it to the pizza. If they gave us some input that was not any of these, we're just going to continue asking from the top. So if I run this, what topping would you like? Enter quit when complete. I need to go ahead and enter this. Let me go to rerun. Quit. Let's clear this out. Let's get some space here. Tilde here. Okay, enter quit. We want cheese. Cheese added to pizza. Okay, what topping would you like? We want peppers. We want let's print for topping in so now if we break out of this loop, so if I point here, clear. So if we go to cheese, peppers, and then let's do ham. So now after each time we add the ingredient and it doesn't say quit, it's going to reiterate that it added the topping. Ham added to pizza. What topping would you like again? Now, if we say quit, I wanted to see what kind of pizza we have, right? So for topping in toppings print, for T in toppings, print topping, the T. So we'll quit, and then there you have it. I could probably say like F, like F string here, like this, go topping, your pizza has I'll just keep it like this, and then I'll put like right here. String. Like so. So now if I clear this, so basically I just added a little bit of more description to make it more clear to the user as just some practice. So if the quit is detected to make the loop stop and eventually break, before it breaks, I want to just say your pizza has, and then for every topping in the toppings list, I want to actually just print those toppings tabbed. So I can just display the actual pizza to the user. Just as I thought that would be kind of fun to do. So let's go ahead and run this code here. Let's do cheese, peppers, and ham. And then let's quit. Your pizza has cheese, peppers, and ham. Boom! Mmm. Mmm. That's what I'd like to see. Okay, that was pretty nice. That wasn't that bad. Things are starting to heat up, though, as you can see quick here in page 123. As you get past kind of page 100, stuff starts to pick up. So let's go ahead and was that all it wanted? Yeah, I think so. Cool. Let's go ahead and do a new file for 7-5. Movie tickets. Okay, .py. All right, so a movie theater charges different ticket prices depending on a person's age. If a person is under 3, age of 3, the ticket is free. If they're between 3 and 12, the ticket is $10. And age over 12, the ticket is $15. Write a loop in which you ask the user for their age and tell them the cost of their movie ticket. Okay. I need to use the restroom real quick. I did not do that during my break, unfortunately. So I'm gonna go ahead and take a look quick. I can work through this one, then I'll go to the bathroom. This one's not that hard. So we want. So we just need to while true a so I'm gonna say allowed, or I'm gonna say permitted. I don't even know how to spell allowed. Let's just say allowed is equal to true. So while allowed, let's just say adult. Oh no. Oh, this is just doing a. Okay, so let's just keep it simple here. Just wanting to keep it simple. So 7-5. Movie tickets. A movie theater charges different ticket prices depending on a person's age. If a person is under the age of 3, the ticket is free. So if age is less than 3, print quote free. Okay. If age in range 3 to 13. Ticket is equal to $10. We want to do ticket is equal to 0. Price starts at 0. All right. So we're gonna update this variable. Actually, is what I'm gonna do. So we start off with an empty variable of price. If the age of the person is 3, the ticket, we're gonna update the price to keep the price at 0. Continue. We're gonna continue actually. Continue asking because I'm gonna format a while loop here. So while true, if age is equal to 3, continue the prompt because it's free. Um, print is price, whatever. So your ticket is the price. Continue the loop. LF age is in range 3 to 13. Ticket is equal to update ticket to $10. And we want to print this again. And so then we'll just copy this one last time. Or we'll say LF age is, if they're over 12, greater than 12, we are going to update the ticket value to 15. We need a $sign. Print this. We want to continue the loop. While true, so we want to get an input. Age is equal to input. We need to convert it to an integer. Age is equal to input, so what is your age? Okay. So if the age Okay, so let's just recap this quickly here. So I have a price variable just to store the initial price of 0, which would be, it doesn't tell me a default price to do anything, so I'm just going to assume it's 0. So while we're wanting to continually ask these people their ages, let's say, what is your age? We're going to ask them in the form of a variable age, what is their age? And we're going to convert that string to an integer because they're going to give us a number. Now, normally you'd probably do some try except thing from what I've learned in the past, to specify that the user needs to input a integer here rather than typing THREE as in 3. But we're not worried about that right now. So age equals to input what is your age. Now, if the age is equal to quote quit, we want to break. So we need to specify actually first here. Specify what is your age. Let's go press enter quote quit to end. To stop. Okay. To exit. So now if I go ahead and run this bad boy, let's go ahead and clear this out. Ooh, missing something here after this guy. Boom. Okay, let's try that one last time here. Ooh, what's going on? I don't want repel. No, I don't want repel. Repel. I want this guy. No, command enter. There we go. So let me also just go like this. Give us more. Quit. What's it running here? Okay, so actually I cannot convert it yet because I want the user to say quit. Um, quit. Mm-hmm. I don't think this will work. Yeah, so I can't convert. So, but I need to first take age and convert it to an integer here. So if age, if int age so if the user age is equal to quit, if you can integer age, else we're just gonna break. Print. So let's recap here. So we have a price variable. While true, we're going to keep asking the user for their age. If they want to quit, they can enter quit to exit. If the user enters quit, we'll break the loop. If we can convert the user's age to an integer, we're going to go ahead and perform the analysis. Else, we're going to break with invalid input. If age is less than 3, we're going to print the price is free. The print price is equal to 0. And we'll continue the loop. Elif age is equal to range is in the range. Elif if the age is in the range of 3 to 13 excluded, we're going to update ticket price price to 10 and price 15. What is your age? 3. So why is my int conversion here not working? So if int age, we are going to int age. If we can int the age, else break. Let's try that. Huh. Less than, not supported between just a string and integer. If I run this again, I go quit. It quits. Okay. So what if I get rid of the int statement here? Go like this. If age is equal to int, can I do that? It's not an int because it's converting. Why is this so much harder than it needs to be? It doesn't make any. See, the AI is wanting me to use try except statements like I had brought up earlier. But this, I don't think I had learned about, like, error checking yet. See, like, we didn't learn about try and accept statements. So movie theater charges 3 different ticket prices depending on person's age. If the person is under the age of 3, the ticket's free. If they're depending on the tickets, $10. If they are over the age of 12, the ticket's $15. Already leave the ask user for the age and tell them the cost of the movie ticket. Right? 3 different versions are $4.75. I'm not gonna do this guy here. I'm not gonna do this guy because it's just the same thing I've been doing, or the infinity one. So in movie theater charges, so we have price is equal to 0. While true, how did you? So I don't really like this problem because it's an easy one, but what? I want to see Eric Matthes, 7. Huh. Cheat sheets? Oh, wow. Okay, so it wants a break statement used when the user enters quit. But they can't enter quit if I'm converting to a string or to an integer. So what would I have to do? What if I would have to detect it by saying is digit method. Do I have that method unlocked here? Methods, list methods, dictionary methods. What about string integers? So I could use is digit method, right? So if age is digit, we'll go ahead and int age. Delete this. Okay, so while true, look at We'll get an input value from the user, asking them what their age is, and to enter quit to exit. If they entered quit, let's go ahead and break the loop. If age is a digit, is a number, we're going to convert age to input and then do these checks. Like so. What? Oh, I'm not storing it in anything. So just by inting the age in that one instance doesn't carry it over. So now if I run this, I'm going to do 1. 0. What? Else statement here. Oh. It's not updating. So I need price to go inside the loop to reset price to 0 at the start of every loop. So now if I control C out of this, I clear. and I run here. Run 1, 2, 0, 10, 0, 0, 0, 10. Cool. All right, so that one took me a little bit to kind of wrap my head around because it in the instructions for movie tickets says movie theater charges different tickets depending on a person's age. If a person's age is under 3, I can check all these, but when I kind of look down here to complete the 7-6 at the same time, it wants me to use a conditional test in the while statement to stop the loop. So it wants me to then like edit like while like allowed and have age be like on and off. Control how long the loop runs. Use a break statement, the quick value. So for mine, before the price was just being set at 0, and then during the loop wasn't ever updating. Well, it was updating, but then it wasn't resetting rather back to 0. So I put the price inside of my while loop so that every time it runs off of one of these continue statements, it resets my price back to 0 and then prompts again. Um, the only thing that's strange though is when you need to specify within the same variable whether something is integer or string via asking the user to say quit or to input their age as in form of a number. You can't compare these two instances, and so you have to detect it with this is digit method. Now, I don't remember us learning about this. I went ahead and looked this one up, but this just detects, obviously as in the name, whether it's a digit or not, or whether it's a number. So, I mean, you could probably use like regular expression for more advanced people that know what that is, to detect like using what is it \d is the code for any number 0 to 9. So you could do, um, you know, caret \d and then make the second \d optional for the second digit for the tens and ones place. I'd have to look back on the regular expression notes, but so anyways, we had to detect if there was an age. So if the age was actually a digit entered into here, we then needed to convert the age to integer. Now you can't just say int age if int age, because it doesn't return true value, true or false. It doesn't return a bool. So we had to reassign age to the int age and then perform our checks. Yeah, that was that one. So I'm not going to do 7-6 and 7-7. I believe that they get worked in as you work through these ones. 124. We're almost there. Almost there. Oh, we got somebody in here actually. Hello, hello. Welcome. How you doing? Let's pull up my chat here so I can see if anything was actually said. Can't see anything there. Docs, chat. Hold on, let me open up my Safari here to open up my stream. bear with me here. Hold on, let me. Yo, what's up, Vile Vortex? How you doing, man? Welcome back. Good to see you again. Yeah, I took a little I if you watch the beginning of the live when it republishes, I went ahead and took a small break. I was on a vacation, went to go see my parents, but I was working on my final project for CS50P, um, which I actually completed a couple of days ago, and I was working on that, and I didn't stream it because I have some confidentiality with that one. Like I said, I wanted to integrate it with my work, and so I had to keep a little bit of uh, discretion with that one. But I am back on the grind for Python Crash Course, though. I did have to take a small break while I was working on that. I wanted to complete that course and get it out of the way, but yes, I am back here. But right now, I'm working on while loops, and in chapter 7. Again, I've already went over this stuff in my CS50P course, but I wanted to solidify it further and really get it solid. So we're on page 124, using a while loop with dictionaries and lists. So far, we've worked with only one piece of user information at a time. We received the user's input and then printed the input or response to it. The next time through the while loop, we'd receive another input value and respond to that. But to keep track of many users and pieces of information, we'll need to use lists and dictionaries with our while loops. A for loop is effective for looping through a list, but you shouldn't modify a list inside of a for loop because Python will have trouble keeping track of the items in the list. All right, to modify a list inside of a for loop, or to modify a list as you work through it, use a while loop. While using while loops with lists and dictionaries allows you to collect, store, and organize lots of input to examine and report on later. Okay. Moving items from one list to another. Consider a list of newly generated but unverified users of a website. After we verify these users, how can we improve them? How can we move them to a separate list of confirmed users? One way would be to use a while loop to pull users from the list of unconfirmed users as we verify them and then add them to a separate list of confirmed users. Here's what that might look like. Okay, so we're going to start with users that need to be verified and an empty list to hold confirmed users. So we have a list of our unconfirmed users in line 1 here, and then we have the empty list. So then we need to verify each user until there are no more confirmed users, and move each verified user into the list of confirmed users. So while there are unconfirmed users, current user equals unconfirmed user dot pop. So we're going to pop out of the list the unconfirmed user, save it as a current user variable. Okay, and then print verifying user, boom, the current user dot title, and then append the current user to the confirmed users list. How you been, Wild Vortex? You have anything going on in the past couple weeks? How's your studies been with Python and other things? Hopefully you've been on top of it. Okay, so yeah, so we have this list of users and we have a blank list. While we have users in this list, while there are users in this list, we're going to go ahead and pop each one of them out, save it to this current user for each one, and then append it to our confirmed users list. And then display all confirmed users, print the following users have been confirmed for confirmed user and confirmed users, print confirmed user title. Iterate over every user in the confirmed users list and print it, the user, okay? So we begin, let me bring this up here. We begin with a list of unconfirmed users, Alice, Brian, and Candace, and an empty list to hold confirmed users. The while loop runs as long as the list of unconfirmed users is not empty. Within this loop, the pop method removes unverified users one at a time from the end of the unconfirmed users. Because Candace is the last unconfirmed user in the list, her name will be the first to be removed, assigned to current user, and added to confirmed users list. Next, Brian, then Alice. We simulate confirming each user by printing a verification message and then adding them to the list of confirmed users. As the list of unconfirmed users shrinks, the list of confirmed users grows. When the list of unconfirmed users is empty, the loop stops and the list of confirmed users is printed. Cool. So, yeah, that can be pretty difficult to kind of wrap your head around because of the syntax, like the unconfirmed users, confirmed users, current user. It can get kind of hard to understand in your brain, but it's a fairly simple task if you just break it down. We have a list of people, original people that are not confirmed. We have a blank list of confirmed users. So there's no one in there. So we're gonna, while there are people in the unconfirmed users list, while there's people in there, until it's empty, let's go ahead and pop the end user out, each one individually via this function here, method. And then go ahead and just print a message, display that we're verifying them, and go ahead and just add that user to the confirmed user list. So just moving from one to the other and kind of simulating this confirmation. Now, in order to confirm something, you would want to, check against some sort of condition, like are they already, do they have an account or is it a username or something? But we're not worried about that right now. Okay, so removing all instances of specific values from a list. In chapter 3, we used remove to remove a specific value from a list. The remove function worked because the value we were interested in appeared only once in the list. But what if you want to remove all instances of a value from a list? Say you have a list of pets with the value cat repeated several times. To remove all instances of that value, you can run a while loop until cat is no longer in the list, as shown here. So while cat in pets.remove quote cat, we start with the list containing multiple instances of cat. While printing the list, Python enters the while loop because it finds the value quote cat in the list at least once. Once inside the loop, Python removes the first instance of cat, returns the while to the while line, and then re-enters the loop. When it finds that cat is still in the list, it removes each instance of cat until the value is no longer in the list, at which Python exits the loop and prints the list again. That one was pretty easy. So you have a list here with, multiple occurrences of the same value. So you can use a while loop while there is, a cat value in this list pets, we're going to remove the cat values until there's no more and then print pets. So filling a dictionary with user input. You can prompt for as much input as you need in each pass through a while loop. Let's make a polling program in which each pass through the loop prompts for the participant's name and response. We'll store the data we gathered in a dictionary because we want to connect each response with a particular user. Okay, you can prompt for as much input as you need in each pass through a while loop. Let's make a polling program which each pass through the loop prompts for the participant's name and response. We'll store the data in a dictionary. Okay, so responses is this blank dictionary. Set a flag to indicate that the polling is active. So we're going to set this flag to that we're active. While polling active, prompt the person's name and response. Name is input your name, response. Input which mountain would you like to climb someday. Store the response in the name in the dictionary. Responses key name equals response. Okay, find out if anyone else is going to take the poll. So repeat, would anyone like to? No. Turn it off. Turn the poll to false. Let's complete all results. The program first defines an empty dictionary responses and sets a flag polling underscore active to indicate that polling is active. As long as polling active is true, Python will run the code in the while loop. Within the loop, the user is prompted to enter their name and mountain they like to climb. That information is stored in the responses dictionary, and the user is asked whether or not to keep the poll running. If they enter yes, the program enters the while loop again. If they enter no, the polling active flag is set to false. The while loop stops running, and the final code at block 4 displays the poll results. And the user is asked whether or not to keep the poll running. So by default, there is no continue specified right here. So like if yes, continue. So I'm pretty sure then it would just infer that the opposite response or response not specified via no would just mean yes. So technically if the user answered like literally like quote poo or apples right here, it would run the loop again. So there are some errors in this code. Potential errors. Well, okay, the program, okay. Okay, so then it says, if you run this program and enter simple responses, you usually say, well, like this, what's your name? Eric. Which mountain would you like to come to? Not only. Would you like, yes. What's your name? Lynn. Gotcha. All right, so we are almost done here. I'm going to take, we're almost there. We can finish up quick here. Almost done with chapter 8 or 7. So sandwich or deli here. Chicken as in the deli. Deli. Okay, make a list called sandwiches owners. Sandwich owners. A list. Sandwiches. Turkey. Got you got a club. Got ham and cheese. Okay. Then make an empty list called finished sandwiches. Okay. Loop through the list of sandwich orders and print a message for each order, such as I made your tuna sandwich. As each individual sandwich is made, move it to the list of finished sandwiches. After all sandwiches, print a message listing sandwiches made. So while sandwich orders, while there are sandwich orders, um, for sandwich and which hate spelling sandwich. For sandwich and sandwich orders, print F I made your sandwich. Okay. Then we want to current sandwich is equal to we're going to pop out that sandwich, and then we're going to append the current sandwich that we're on. Right, this is pretty similar to the example that was shown. So we actually don't want this. We want to put this here, current sandwich equals sandwich.pop. We want to delete this and put the current sandwich in here. We want to grab the sandwich with it, print which one we grabbed, move it over. And then now that that's over, let me move to this. Print current sandwiches would be we need to iterate over each one for each sandwich and finished So we have an empty list of sandwich orders, or we have a sandwich orders, which are current orders live. We have an empty list of finished orders. While there are sandwich orders in the queue, we want to take the end one. We want to pop it out, take an end one, pop it out, and assign it to current sandwich. We want to specify that it was made, and that we want to move it over to the finished sandwiches list. Once that happens, for each one of those, boom, 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 we're going to move on to this, print out the finished sandwiches, and then for every sandwich in my finished sandwiches list, we want to print out the sandwich in tab. So if we go ahead and clear, or Control C. Line 7. Oh. Okay, like so. Like so. Cool. Sweet, that one's done. Moving on here to 7-9. No pastrami. Pie. Using the list sandwich orders from exercise 7-8, make sure the sandwich pastrami appears in the list at least 3 times. Okay, put it up here. We'll put it right here. Okay. Make sure your response appears on those 3 times. Add code near the beginning of your program to print a message saying the deli has ran out of pastrami, and then use a while loop to print a message of all occurrences of pastrami to remove all occurrences from sandwich orders. Okay, so print we are out of Okay, we are out of pastrami. So while there are sandwich orders, so while quote pastrami in sandwich orders, sand orders dot remove quote pastrami. Um, okay, so it wants me to use this guy, I think. Right here. Okay, while sandwich orders, current sandwich. So we need to say out of pastrami. So while there are sandwich orders, current sandwich equals sandwich orders dot. In sandwich orders. I think this will work. So while there's pastrami in the sandwich orders, we're going to pop out each one by one. If that current sandwich is equal to pastrami, we want to
not right either. There we go. Turkey Club.
Nice. Okay, got that one. So that one was a little bit more challenging. So we have sandwich orders, which we have pastrami listed 3 times, and we have the finished sandwiches. We display first that we were out of pastrami. So while we have sandwich orders, or while we have data inside this list, sandwich orders, we're going to pop each one starting from the end out using the pop method and assign it to the current sandwich variable. If that current sandwich that we're on is equal to quote pastrami, we're going to um, we're going to continue the loop. We're just going to skip over it and not do anything with it. But if it's not, we're going to append it to the finished sandwiches, which is what we get here. Cool. So 7 underscore 10 underscore dream vacation dot py. Write a program that pulls users about their dream vacation. Write a prompt similar to if you could visit one place in the world, where would you go? Include a block of code that prints the results for the pull. Write a program that pulls users about their dream vacation. So it wants me to use a poll. Write a program that pulls users about their dream vacation. Write a prompt similar to if you could. So input. If you could visit one place in the world, where would you go?
Store this as place. So we're gonna do while status true. While status status whatever. We're gonna get a prompt. User, would you like to go? Bug. What is your name? Okay, I'm gonna push it go. While status.
So
So we need to go up here and go vacations equals to an empty dictionary. So we're gonna go vacations, we're gonna access the key, we're gonna place the key value as name, and we're gonna assign the value to place. Add another response, no, we want to break the loop. We want to print. Line 16, print F. Vacations name. Would you like to travel to vacations place? So I'll use the items for response. So it'd be for name. Yeah. Be name, place, in vacations dot. We need to separate them. And now we should be able to print this. Mike, Portland, John, Seattle. Oh, so it would just be not name, vacations name, but just name and just place because we're calling those, we're unpacking name and place out of this. So if I run here, what is your name? Mike. I want to go to Portland. Yes. John, I want to go to Seattle. No. Mike would like to travel to Portland. John would like to travel to Seattle. So we go name dot title dot title. Now we run this for Mike. Portland. John, Seattle. Or John, Seattle. No. Boom! So right program pulls user other communication right program. This would be status false. Would not be break. Status equals false. Nice. So now if I copy this, everything should work. Woo! Nice, guys. All right, feeling good about a lot of practice today with while loops. I will go ahead and I'm going to just read the summary. So, in this chapter, you learned how to use the input to allow users to provide their own information to your programs. You learned how to work with both text and numerical input and how to use while loops to make your programs run as long as the users want them to. You saw several ways to control the flow of a while loop by setting a active flag, using break statements, and using a continue statement. You learn how to write a while loop to move items from one list to another, how to remove all instances of a value from a list. You also learned how while loops can be used with dictionaries. In Chapter 8, you'll learn about functions. Functions allow you to break your program into smaller parts. Each of
which does one specific job. You can call a function as many times as you want, and you can store your functions in separate files. By using functions, you'll be able to write more efficient code that's easier to troubleshoot and maintain, and that can be reused in many different programs. I'm actually going to go back to the beginning of chapter 7 here, because it did talk about how it specified integers versus strings. Here we go. Using int to accept numerical input on page 115. The modulo operator. So I could have said in that previous one, rather than saying like converting to int, I could have said like if a number int number, convert the number to int, the input value to int is equal to true, then do this. So, or while their input is equal to a number, while int number is equal to true. Yeah. Cool. So that finishes up with page 27 and 28. Next is going to be 29, chapter 8, functions. I really appreciate everybody for joining in. If you stopped in today, if you're watching the VOD back, thanks for checking it out and for learning along with me and just grinding through Python, learning as I go from beginner to end, from 0 to wherever I go. I appreciate you guys joining me on today was the 10th of September of 2024. This has been the 3rd edition of Python Crash